Well, you have our attention.
Thank you. Good to meet you all, both here in the room and virtually. We'll be talking about the new energy which is coming out very soon, which is needed. And consumption versus generation is of importance. You need energy to consume. And electricity is nowadays 20% of the world's energy consumption. In the future, it will be the backbone of the entire energy system. And by 2050, it's estimated that we'll need 2 to 4 times more electricity than today. And 3 times as much transmission capacity, which is difficult coming from the mountains, going to urban areas, but coming from the seaside, it's much more easy. And 40% of the hours of the month, there's minimum wind and no sun, powered by fossils nowadays. And if you 10 double the amount of wind plus solar, we'll still have 40% powered by fossils mainly. And if we're now doubling the amount of electricity, then we are also doubling the amount of fossils, aren't we? If we don't solve this problem. And I'm happy to say that me and my team, we can work every day on solving this huge problem. By NoviOcean, our concept is the hydropower plant at sea. We install the hydropower plant from up in the mountains, put it down on the float, coupled to a hydraulic cylinder. 3 parts, very simple. And our mission is saving the climate with profitable wave power. You see it up to the right, out to sea in Stockholm for 5 months of testing, successful testing last year, and below that with students from the universities 3 years before. Our goals is to deliver stable energy from the oceans at a lower price than offshore wind. Big challenge. And to globally deploy thousands of units over the coming decades. And to play a vital role in mitigating the climate crisis on the huge global market. And this will be done due to our essentials. And those are weight to power ratio is 1/2 versus floating offshore wind. And of course, less metal, you save money and you have less emissions. Number of parts is 1/2 versus offshore wind. Means it's simpler, have a lower capex and lower opex. Sea area used is also 1/2 versus offshore wind. You get double the amount of power per sea area, and of course, if you combine it with wind power, it's even better. And the LCOE, the cost per megawatt hour, is 1/3 versus start of offshore wind and sun power, meaning you're rapidly approaching their cost and then possibly going below. And why is that important? Because it's much more stable. The base load, the lowest you get per month, is up to 3 times higher than wind power. It's a better energy source. And if you combine those two, wind power and wave power can have a 5 times higher base load. Essential. Why? Because you can use less fossils and less storage, because it's much more stable. Alrighty, how it works. You see here a 38-meter float, later on 60 meters long, coupled to a hydraulic cylinder filled with water, and on top the hydropower plant. Very simple. All right, we'll start it up. Flows first like a surfboard, and here it goes. Water is rising on the side, it's locked hydraulically, and there it stops. Now you can see we have a high pressure in the lower end of the cylinder, and then if Stefan, maybe I can start it here. Ah, shit, sorry. Let's see, do it one more time. No. I think you have to help me, Stefan. Start it. So here it goes upwards, pressurizing 600 tons of water, and there you have 1,500 liters of water hitting that turbine with up to 300 kilometers per hour, bang, every second, creating 5 megawatts in the lifting phase. Very simple, and it's very unique in comparison to anything else out there. And then it goes down in the wave again and repeats that cycle 10,000 times per day. All right, wind and waves are off-phased, very important. Up left, you can see outside Ireland for 2 weeks with wind power. And you can see that it's very often down to just 10% for 10 days a month, meaning that all the white area is today mainly powered by fossils. That's what we're fighting against, aren't we? But below, you can see wave power in the same location for the same period. It's much more stable. It is, if I may say so, a better energy source than wind power. But we need to work together. I'll show you why. In this one, you can see that you have low wind power and high wave power at the same time. They're complementary. And in the lowest graph, you can see that the white area is a much less percentage than in the top left graph. So if you combine those two sources, it's the best for the grids and for the users. We have a hybrid solution. It is 500 kilowatt of wave power and 120 kilowatt of solar, 2.7 gigawatt hours per year. And we call it H-PAS concept, hydropower plant at sea, as mentioned. 3 patents. It has few, light, simple, and well-proven components. And we can offer then PV panels on top, going also out to the side, 700 square meters. Also have storage on board, plus H2 production later on. And other floating solar solutions, they have 75% the cost for only the structure, the cable, and the system. Well, we already have that on board, so we don't need that. So the hybrid puts together this thing in a much more economical way than just having floating solar by itself. We said the proof is in the pudding. We have the numbers, and we show them. This is offshore testing last year, outside of Stockholm, actually. The numbers show basically all the performance data and the simulations, and they match perfectly well. We have proven that the simulations are correct. And then, when we extrapolate those simulations to the full scale, you can see lower right is 1 megawatt of power. No one else in the sector shows something similar. So we have validated it will work in full scale, where we're going. Gives you some hope, I hope. And then the cost, what is it? On the left side, you will see 200 euros per megawatt hour, or 20 cents per kilowatt hour, directly from start. And then after 100 megawatt in the water, you're down to 50% of that, down to 100 euros, 10 cents per kilowatt hour. And you get paid about 250 from Canada, UK, and Taiwan so far. More countries are coming in, plus 2,000 islands globally running on diesel. They have a higher cost than this. So where are we? We finished with stage 1, stage 2, and now also stage 3, going into full-scale design and construction, and then afterwards pre-commercial and commercial array. Should be in the water in less than 3 years outside of Spain in Biscay Bay. And we have a core team of 6 persons full-time. And for those listening, we're now looking for a commercial director to help us spread this world out in the world. And of course, anyone else that wants to help or work with something sensible and important, welcome to send me your CVs for the future. And then we're looking for some more. We have 3 million funded so far by grants. We will apply for 2 more this summer. We're looking for 10 million to put this thing into production, the first unit, and to order the components. And we ask then large partners, utility companies, oil and gas companies, industrial companies, shipyards to come on board. And why should they not just wait on the sideline as they normally do? Well, if they wait on the sidelines, we will have 1 or 2 partners, and those partners will have exclusivity for regions over their operations for 15 years. So if you wait, you might not be able to get what we have, and we cannot produce for anyone so far. So come on board, Enel, EDP, Engie, EDF, Shell, BP, Equinor, Damon, and Aker. Give me a call, and we can talk about this. Also, investors are applicable here. And then finally, go to our homepage,